Hey, what's going on, guys? Let's do this problem right here. The question is asking 200 microcoulomb charge is placed at the origin and negative 300 microcoulomb is placed 1 meter to the right of it. What is the magnitude and direction of the electric field midway between the two charges and 30 centimeter to the right of the negative charge? So let's see how we can calculate this one. First of all, they are saying we have a positive charge right here. So we have a positive charge in the origin, and from that 1 meter away we have a negative charge, and they have given the value of these charges. The first one is 200 microcoulomb and the second one is 300 microcoulomb. It's negative, right? And also 1 meter, and the first question is asking what is the electric field midway between the two charges. So midway means it's going to be here, right? So this is our point. We are going to calculate the electric field. First of all, we have to know the direction of these charges toward this one. So let's say this is Q1, this is Q2 charge, and first of all we have to understand what is the behavior of these charges. For electric charge with positive sign, the electric field is always going to be acting away from this one. So it's going to go away, right? And for a negative charge, it goes toward that one, right? So this is how electric field behave. So here we are taking midpoint. We have to know in which way this charge is going to travel toward this point. So if you notice, this is going away from this one, so this is going to go like this. So this is going to be our E1 direction, and E2, as I discussed, for negative charge is go toward this one, but we have to have a point that's passed through this one, right? If I take here, it doesn't work because it goes other direction. So from here to here, it's going to be go toward this one, right? So this is also in the same direction. So this is E2. And to find the electric field, since both are in the same direction, we have to add them together. E net is going to be equal to E1 plus E2. So let's do the calculation. So here, if you notice, the only difference is this distance from here is going to be 0.5. From here to here is going to be 0.5. Therefore, if I say R1 and R2, if this is R1 and this is R2, both are same thing, so we can say R. So we are going to use KQ over R square equation. Since both of the radius are equal, we can take that one common. K and R square is going to be same thing for both of them, but the only difference is Q1 and Q2, that's charge. 200 microcoulomb and 300 microcoulomb. We can avoid this negative sign because they are asking for the magnitude, so we don't want to bring this one. So we can add this Q1 plus Q2. So this is going to be our equation. Let's plug all the values. So we have K, that is 9 times 10 to the power of 9 Newton per coulomb, and Q1 is 200 microcoulomb. We can write this one as 200 times 10 to the power of minus 9 coulomb plus 300 times 10 to the power of minus 9 coulomb divided by R square. R square is basically 0.5 square, 0.5 meter square, and if you calculate this value, you will get 1.8 times 10 to the power of 7 Newton per coulomb. So this is the answer for the first question. So they are asking for the midway between two charges. We calculate that one, that's this one. And the second condition, they are saying, the second condition, if it's 30 centimeter to the right of the negative charge. So let's draw this one again. So we have a positive charge right here, and negative charge. Both are 1 meter away. 1 meter away, let's say Q1, Q2, and we know the values. And they are saying 30 centimeter away. So it means 0.3 meter. So let's say this is the point A. So from here to here 0.3 meter, right? So 0.3 meter away we have another point A. So what is the to the right of the negative charge? So they are asking to find the electric field at that point. So according to this information, we know that for A value, this is going to go through the positive charge. If it's Q1, E1 is going to be going through this charge, and for negative charge, it's going to pass toward this charge. So this is going to be E2, right? So this is how it's going to happen. Since both are in the negative direction, in this case we are going to deduct each other. So here we have this one 200 microcoulomb, and this is in 300 microcoulomb. From this one we know that definitely, since this is also closer and bigger than the Q1, the net force is going to be according to E2 direction. E2 is, I'm taking the Q2's direction. E2, so E2 is bigger than this one, so net is going to be in this direction, since this is bigger than that, right? So that's that we know, and let's do the equation. We have E net is equal to E1 minus E2, E1 minus E2. Here the radius also, R is also going to be different, because for the Q1 it's going to be from here to here all the way right here, right, to A, that is 1.3. For Q2 it's just 0.3 meter distance. So let's do the calculation. So I'm going to use KQ over R square. So here K is the only thing that is same for each of this, and Q over R square going to be different. So we can say take the K common, Q1 over R1 square plus Q2 over, is subtracting, right? We are deducting each other because both are in the opposite direction. So minus Q2 over R2 square. So as we said before, since we are calculating the magnitude, we don't have to bring this negative sign here. We just put 300 and calculate the value. So let's plug all the values. So K is going to be 9 times 10 to the power 9 Newton per Coulomb, multiplied by Q1, that is 200 times 10 to the power of minus 9 Coulomb, divided by R1 square, that is 1.3 square, minus Q2, that is 300 microcoulomb. So 300 times 10 to the power 300 times 10 to the power of minus 9 divided by 0.3 square. So this is the expression. Now let's calculate all the values. If you calculate this value, you will get negative 2.8935 times 10 to the power of 7. Since they are asking for the magnitude, we can put it as positive 2.89 times 10 to the power of 7 Newton per Coulomb, and that is our final answer. I hope you guys like this video. See you next time.